monitoring module where we can at least get data from them and apply it in a way which can be used for power prediction of diseases.
But your mosquito control programs are run by the same department as the department?
For mosquito controlling, we don't have like a separate field of this, but most all the diseases we have anthropologists doing their mosquito control, but it's made manually, which is another like a weak side, and the number of mosquitoes which is controlled remains to be really low.
Okay, let's move on to our next speaker. Thank you so much for the talk. And now we have Jessica Williams, who's going to talk us about ethical and equitable approaches in AI.
Yeah, there's something a bit different now. So yes, as Jane said, we're going to talk about the ethical and equitable considerations, which can sometimes get left behind as we get a bit overexcited about our technologies, which is completely understandable. But yes. So first of all, this paper was a huge effort, a very much a team effort from a group of us within Vector AI. So I want to say a huge thank you to the other co-authors. And I also want to thank some people from a workshop we had in last year from Working Group 1 who gave us some feedback on an early version of the paper. This is a huge topic and I won't be able to get through it all today. So if you do find this interesting, I would encourage you to please to head to the paper and have a read. But I'll cover a few interesting bits today. So first of all, what are vector-borne diseases? Well, they're infectious illnesses affecting humans caused by bioparasites, bacteria, which are transmitted by living organisms. And these living organisms are the ones we call the vectors. So examples of this, some of what we just heard, include malaria, Zika, West Nile virus, and Lyme disease. And these have often been termed a wicked problem. They cause over 700,000 deaths annually and are a huge burden and risk to much of the world's population. And the integration of AI into the management and control of vector-borne diseases is really exciting, and we think it has potential to really factors, such as surveillance, prediction, and control. A couple of examples of this. So thinking about surveillance, there have been systems which have combined things such as the Vectrac system with commercial tracking devices. And the Vectrac system integrates infrared optical sensors with supervised machine learning algorithms, specifically random forest and gradient boosting classifiers, to analyze wing beat frequencies and classify adult mosquitoes by genus and sex. And in terms of control, there's been some really cool work using explainable AI to look at how we can differentiate mosquitoes which are susceptible and resistant to insecticides by looking at their flight trajectories. However, when we're integrating AI into public health interventions, these have a direct impact on individual and community well-being. And it really means that we need to have a really consider the ethical and equitable considerations. And there are distinct features of AI which makes this even more important, such as its potential lack of transparency, the autonomous learning capacity, and the reliance on vast data sets. So in this paper, we wanted to summarise some of the key ethical and equity challenges in the use of AI for vector-borne disease control and propose actionable pathways forward. And our overall aim was to advocate for technological innovations that also advance in ways to protect the well-being of people and the planet. I should note that when I talk about AI within this talk and in the paper, we're focusing on AI software. So those are the data, code, and models. We're not thinking about the hardware, which some of the challenges do overlap, but also it's a very different ballgame. So within our paper, we covered 7 different interlinked and key challenge areas. We looked at data quality and representativeness, the risk of discrimination and reinforcement of inequalities, algorithmic transparency and the reproducibility of AI models, privacy and data protection, patient safety and cybersecurity, fair and equitable benefit sharing, and the environmental and ecological considerations of AI use. And today I'm just going to cover 3 of these. As I said, we don't have much time, but please do go to the paper if you're interested in others. So the first thing I'm going to cover is data quality and representativeness. And for each challenge, we kind of lay out the challenge. And as I said, we then lay out kind of actionable pathways forward. So within this challenge, as we all know, robust AI systems require really high quality, representative and contextually relevant data. And without this, it can lead to models which limited validity and potentially harmful outcomes. And unfortunately, over 60% of the countries that are affected by vector-borne diseases lack their systems available for routine entomological and epidemiological data collection. And without this, it can result in incomplete or skewed data, which could result in inaccurate risk maps, ineffective interventions, and misallocation of limited resources. So that should say a number of major vector-borne diseases. So how do we overcome this? Well, we looked at a few solutions and we split these into 4 groups. I blame Google Slides for that was all on one line at the top. So we looked at technical, methodological, institutional, and in the field pathways forward. So technically, we were advocating standardized data collection, annotation, validation, and also automated tools for identifying anomalies in the data early on. Methodologically, we advocated active learning or few-shot learning or even agile modeling to build robust models with limited data. There's also data augmentation or generative models to expand dataset variability, which can help as well. It's also key to be able to fill in those gaps we have in the data. And so collaborative networks can really help with this and data sharing initiatives. And there's some great examples of this, such as the Malaria Atlas project and the Global Vector Hub. In the field as well, targeted data collection, participatory data collection models and capacity building programs can all help fill in that data gap and strengthen local surveillance. The second topic I'm going to talk about is fair and equitable benefit sharing. Now, there are global disparities in technical infrastructure, expertise and financial resources. And this often leads to privileged that are most likely to benefit from AI and digital resources. And unfortunately, it's often the case that the communities with the highest disease burden are those that lack access to these tools. So this is known as the digital divide, but there also are other reasons leading to this digital divide, which could be barriers in personal beliefs, like cultural barriers and personal beliefs, which leads to different levels of acceptance and uptake of AI technologies. Unfortunately as well, there is sometimes an imbalance between those collecting the data and those recognised. So for example, sometimes we see that people collecting such as image data in the global south areas are not recognised with authorship, financial reward, or even access to the interventions, despite them collecting the data which inform the models. So again, pathways forward. Technically, we really advocate for AI tools to be designed for low resource settings. And there are some examples of this, such as the low-cost tiny ML models, and that paper cited there. Economically, we need to bridge the technological gaps, and that can be done through philanthropic support, international development programs, which should also provide support for infrastructure, capacity building and training. Institutionally, adoption of fair data principles is really important. And it should all, like any interventions or even device, should always be designed with local context in mind. And therefore, kind of community participation is essential. And we are a big fan of convergent science, which is getting all the stakeholders involved right from the start, with co-design all the way through to implementation. And a non-AI example of why this is so important are mosquito nets in Burkina Faso. So there was quite a low uptake of white mosquito nets, but there was a much higher uptake found if the mosquito nets were green. And this was found because white is often used in death rituals, so that's the reason leading to the low uptake. The third area I'm going to cover is environmental considerations. So despite this figure calling it big AI's dirty secret, it's not that much of a secret. AI is very intensive in terms of energy and water use. And this also leads to ethical and equity issues as well. So it's been estimated that health damages from AI emissions will reach 20 billion annually in not very long, so in 4 years, with those households that are vulnerable often facing a much greater burden. The emissions and data backups and generate also been found to worsen respiratory illnesses in marginalised areas. And it also links to ecology as well. So there's a risk that interventions guided by AI only to functional negative ecological impacts if they're applied without local adaptation to ecologically distinct areas. So what the pathways forward? Really trying to design energy and water efficient systems is crucial. And it's also something that's been really great is we've seen that companies are also starting to look at environmental impact assessments for the AI systems, which is a good step forward. Methodologically, transparency is always better. There are also kind of other things you could do, such as using global cloud-based data platforms or pre-registering protocols. And local ground truthing is key, and it's, again, lines up with co-creation and getting kind of all the stakeholders involved. Final thing I'm going to say quickly is at the end of this paper, we looked at ways that using AI ethically and equitably in vector-borne disease management could forward progress to the Sustainable Development Goals. So this is an example of 6 here. Some of them, such as 10, 12, and 13, it's quite obvious. It's quite obvious how using AI ethically and equitably could forward progress towards reducing inequalities, responsible consumption, and climate action. But there are also other ones which may be less obvious, such as the no poverty, quality education, and peace, justice, and for instance. So just one example, for example, no poverty. We thought about how integrating AI technologies into vector-borne disease control and thinking about ethical and equitable considerations could reduce economic losses from illnesses and consequently, hopefully, reduce household poverty. Yeah, so overall, we advocate for transparent, inclusive, and responsible AI use in vector-borne disease management. And we really hope that as AI technologies continue to evolve, that our commitment to using it responsibly also increases, with the well-being of both people and the planet at the forefront. Thank you very much.
Thank you, Jessica. Very refreshing to see ethics of AI actually being discussed and covered. So very nice there. Any questions for Jessica?
Yes.
Is there any taxes of this incentive for responsible use of AI? Anybody looks for penalty for responsible use of AI?
That's a really good question. I don't personally know of any. Do any of my other co-authors in the room know of any?
So there's like presentations of AI environment, right?
Did I say that again?
You are saying that in terms of the impact of the environment, it has some measure of climate methods and their impact on the environment, because different methods have different energy consumption needs. For example, majority of computation.
So this is just an infographic produced by IMD. So it was just more of a
Yeah, this is all, but this is only on full AI, like AI is a very big term to say that all AI is very power hungry. Because if the majority of people are using low cost methods, there's very small devices that are actually powered by solar or something is environmentally unfriendly. We have some kind of measure of how much of these techniques are actually using AI community.
I don't have a measure of all the devices that are being used here today. I'm sorry. But even though like I know like everyone here, well, a lot of people have been talking about using Claude, about using ChatGPT to help with their coding. So it's just those things as well. And those pieces of code we're using to inform kind of vector-borne disease management. So it's not just the devices that we're using, and we were hearing that there's a lot of low cost, low resource tech in this community. It's fantastic, and that is, we really want to highlight that. That's amazing. But it's more, this is kind of a broad overview, and actually there are, even though the particular device might be low cost, the fact that we're using kind of code and other things, it's just got to be environmentally conscious of these things can help.
But the point is that I would decide that something similar happened in plastics. European Union has very strict plastic laws. That's a good thing. But overall, globally, it's a very small percentage of plastic that's coming from the EU environment. And same is for CO2. And I think that there needs to be a ethical consideration, but they need to be like realistic for global usage. We actually have some impact by considering it. I don't know if you know what I mean.
I mean, I personally believe that individual actions do go a long way. I think that's a very personal belief. Not everyone does. I'm vegetarian, for example, because I work in conservation, I work in ecology, and a lot of what I do is on land use change. I don't expect anyone else working on land use change and habitat loss to be vegetarian, but I personally see that if individuals can start up these discussions, bring these topics to the forefront, people might not be thought about these before. Hopefully, example, you have thought about this before, which is fantastic. But I think just opening up the conversation, opening up dialogue about this, raising people's awareness of potential impact, getting us to think about the ethical and equitable considerations when we are building new technologies, when we are using things, I think personally can benefit. And I am hopeful that the more people thinking about this and chatting about it will help.
This is small.
I think let's park it, move us Tom here.
Yeah, I think that's a nice exercise that we could do here as an community. We have lots of people who could quantify this number. Yeah, and we can do this. And we can say something about how, as a technology scales, the size of what.
Another question here?
Thank you for a great presentation. It's really thought inspiring. Like what you started now as a discussion. Did you talk about establishing a kind of set of metrics that could be used by community to estimate like the indirect costs of infrastructure, like data gathering platforms, their maintenance, the AI models running in the cloud. In the future, we will probably only want to have more information, so more models, more different kind of elements. So did you think about that to have some formal way, or at least to formulate the problem of